If you shoot black powder ammunition, or if you just simply shoot lead bullets, perhaps bullets you've cast yourself, sooner or later, no matter how much you clean your gun after firing with things like hops or Outer's solution, you will eventually run into an issue of barrel leading. That's because those cleaners have no effect on lead. They will dissolve copper, they will even in some circumstances dissolve steel, but they will not dissolve barrel lead. There are three really, methods of removing lead from a gun barrel. One method of removing lead is to scrape it. Perhaps a copper screen wrapped around a bore brush, and in many strokes back and forth through the bore. The theory being that the copper will cut the lead but not harm the gun barrel because it is softer than the steel or iron of the gun barrel. And eventually the lead will be removed by the copper screen brushing back and forth against it. The second, more modern method is through the application of electrolysis. Outer's Corporation, until fairly recently, made a solution specifically designed for removing lead fouling from a gun barrel through electrolysis. Regrettably, not enough people purchased the product, so Outer's discontinued it. That would appear to leave everyone high and dry as far as regarding the removal of lead. However, there's an old-timer method dating back to the 1800s, which essentially consists of make a mixture, 50% hydrogen peroxide, 50% white vinegar, stir it together, plug one end of the barrel bore, fill your barrel with it, 20 minutes later, pour the mixture out. In theory, what occurs is the lead in your barrel is then transmuted by this liquid into lead azide. And as lead azide, it is easily removed when you run a patch through. You must get the mixture out of your barrel within 20 minutes, according to the old writings. The reason for that is at about 30 minutes, the vinegar will begin to pit the steel and corrode the steel. It occurred to me, YouTube world would like to see a test of this. Therefore, I have come up with a simple demonstration which will either prove or disprove the effectiveness of hydrogen peroxide and vinegar at removal or dissolving of lead from a gun barrel. What I have here is a jug of vinegar and a bottle of hydrogen peroxide and a measuring cup. I'll use that to make my 50-50 mix. This is a magnet. One of the materials I'm going to test is this piece of 4140 steel. As you can see, it's steel. It's left over from a project I have. 4140 is the metal that many gun barrels and chambers are made of. It's going in this jar. Another item to be tested is this home cast 44 caliber bullet. I messed up on the cast. If the camera will focus, you'll see that the tip of it didn't come out right in the mold because the mold was too hot. Anyway, it's going in this jar. And now I'm going to make my mix. I'm going to pour some of the mix into both jars, and we're going to allow the solutions to sit and work on the metal. If the mix of peroxide and vinegar does dissolve lead, then in a little while the only thing that should be in this jar is a sludge. If it also affects steel, we'll be able to see that because there is no pitting on this metal yet. There's some scarring from a cutting operation, but there is no pitting. So, with no further ado, I'm going to make my mix and add maybe a quarter cup to each jar. Okay, the mix is poured. I don't know if you can see it, but right away the lead bullet has begun bubbling. So something definitely happens when this mixture hits lead. Over here with the steel, nothing at all appears to be happening. What I'm going to do is leave these sit for a while and come back later and see what's left. It has been half an hour since I commenced the experiment. I'm seeing chemical reactions in both. This is the jar that held the steel. You'll notice it's turned a definitely deep red color. I'm not seeing, well, I am seeing a residue forming at the bottom of the jar. I'm not going to discontinue the experiment, but I will say we're 10 minutes past the time. You should have poured the 50-50 mix out of the barrel. I'm told that it turns a disgusting color, but from this chemical reaction, obviously something is also happening with the steel, regardless of what's happening with the lead. This is the jar that holds the lead bullet. You can see the mixture is graying. There's the bullet at the bottom of the jar. And you should, hopefully, this camera's focus will allow you to see as I move it back and forth, that there appears to be a residue, a black residue forming in the jar. And I would assume that black residue is the lead azide we were looking for. I'm going to continue the experiment. Obviously, not only is the water turned gray with the black residue, but there's still foaming occurring on the bullet. I am going to continue the experiment until such time as either I'm convinced all chemical reaction has stopped, or alternatively the reactions won't stop and we'll see what's left of the materials at the bottom of the jar. I'm going to leave it here for at least another few hours, maybe longer, who knows, maybe a week or two. I don't know. I want to see how long this takes to completely dissolve the bullet. Clearly it's started the process, and I'm very curious about what's occurring here with the steel. I don't know what is happening there with the steel. This is clearly way more than just iron oxide rust. This is something else happening. This is a much deeper red than we would get merely from rust. But anyway, this experiment continues. The question being, would a patch or would soaking a barrel in 50-50 mix of peroxide and vinegar actually get lead out? Based on what I'm seeing here, yeah, it'll get some out, but how much it'll take out, I don't know. Maybe if you did this soaking and then did the wire brush or copper mesh afterwards, that would definitely remove more. But anyway, the experiment continues. It's been about 2 hours since the bullet and the piece of steel were put into the respective jars. The jar holding the steel has begun to hiss as gas escapes from the jar, so I've loosened it a bit. Loosened the cap, that is. The jar with the lead in it is already loose, but there's still foaming action occurring. Let's go to these two jars. You can see what I'm seeing. Here we have the jar with the bullet. I don't know if you can see it rolling around or not. Clearly there is, I don't know where the camera will focus, but clearly there's sediment, there's a graying action. I will stir it up and let it sit a minute. And let's go here to this other jar, which this blood red fluid is where the steel is. I'm kind of curious, so I'll open this jar and take the bullet out, or take the steel out rather. Let's see what's occurred to it. The steel is no longer bright and shiny. It definitely has some kind of an oxide coating which smears off. Let's use this rag and see what we got here. Okay. This oxide coating smearing off the metal, coming out of the focus. We're no longer bright and shiny metal. I do not know what this sediment, what it is in there that's red. I can tell you that there does appear to be some kind of pitting occurring. I'm going to let it sit in here because one of the things they warn against is allowing the solution to remain in the barrel for more than 20 minutes. And I'm just going to give it a good run. Somebody more chemically knowledgeable than me might know why I've got this blood red color. I want to say rust, but gee, it's a lot deeper in color than just rust. It really is turning blood red, like red wine. This other jar, again, take the lid off of this. That red bullet is in there, and I think you can see in the center there, we've still got foaming action occurring, so the lead is definitely being broken down. Closing the jar, primarily because it smells of vinegar very strongly. The amount of sediment, however, on the rear, on the bottom, I think you can see that black cloud that's rolling around, settling down. That's less than a gram, hell, less than a grain of lead actually removed after 2 hours of sitting in that solution. So although this solution may indeed dissolve lead in your barrel, it's not going to take very much lead out with a 20-minute soak. Likewise, obviously, it's going to have some kind of an effect on the metal of your rifle or pistol barrel. I'm sure there are better chemical solutions available, but I don't know what they are and I don't know where to buy the ingredients. But this is the historic one, vinegar and hydrogen peroxide, and yes, it does affect the lead, but it obviously, from the red color, affects the steel of your gun barrel too. I don't know what it does to the steel, and again, I'm hoping somebody more chemically knowledgeable than I am has an idea. And if so, please comment and let us know what's happening to the steel. Hopefully you like this, hope you subscribe, and I'm going to let it sit in the solution for a few more hours and see just how red the steel solution gets. Bye-bye. Hi YouTube. It has been 24 hours since the test was begun. There may be better commercial formulations on the market than a 50-50 mix of hydrogen peroxide and vinegar. However, I suspect the ingredients for those formulations are probably not quickly obtainable at Lowe's or Home Depot or Walmart, while the old-time 50-50 mix, peroxide and vinegar, is very much obtainable at just about any place such products are sold. I'm going to terminate the experiment. Like I said, it's been 24 hours. Here's where, I'll put this down a second, show you where we're at. This is the steel. This is the steel. I am being told by friends online the red is probably being caused by chrome or manganese in the metal. The steel has a black coating, which hopefully you can see that. I suspect that is carbon pulled out of the steel. I can't really come up with anything else it could be. The lead bullet pretty much continues to foam. There's a much greater amount of residue on the bottom at this time. I think I'm going to pour this in through a coffee filter and see how much lead was removed. But basically, these two experiments are over. I'm now going to show you what I consider to be the most important step if you are doing this to your barrels. What the old-time gunsmiths said to do, and when I say old-time I mean 1910, 1920, was after treating the barrels with this mixture, pouring it out, and then they said flush it with a patch soaked in bore cleaner. I think I can go a little step better today. This is baking soda and water, and I'm just trying to neutralize any acids. And I don't know if you can see it, but yes, there are bubbles coming off of that steel. And try and get it out for the lead. Give me a second. Okay, here are the two items as removed from after both were treated in the baking soda. I think you can see the soot on the paper towel I used to blot them dry. And of course that's important. If you do this to a barrel, go ahead and blot them dry. The bullet was originally 429, and that can't be right. Let's try this again. I'm in metric mode, excuse me. Okay. Change it again. Yep, that is right. I don't know if you can see this. The bullet diameter, which was a 429 cast, is now down to 372. So clearly a lot of lead, several calibers worth, has been removed. I'm hoping you find this informative. I'll try and give us a close-up later of the steel to see if there was any pitting on it. I'm sure there is. Talk to you in a bit. I'm going to try and capture whatever lead came out. You can see a lot of it in there, right at the edge, the jaw. But I also think I'll see more in a second. Okay, that's all lead azide on the filter paper. I now want to show you a magnified view of the steel, and please try and remember that when this began, it was a machined, semi-polished piece of steel with no pitting. So what have we learned from this? Well, the first obvious method is if you use a 50-50 mix of peroxide and vinegar on your gun barrel, you should be aware that in addition to removal of lead, there is a high chance of some damage to the inside of your gun barrel, specifically in the case of microscopic pits and the removal of materials from the metal itself, such as carbon or manganese or chromium. The removal of those items will of course change the physical properties of the metal itself, so that it might wear faster, and it might even have an effect on the temper of the metal. In all honesty, I'm not a metallurgist. I don't know what effect leaching other elements out of the steel will have on the strength of the barrel or the wear resistance of the barrel, but I certainly think it's something you should consider. And as you could tell in the magnified image, after treating the vinegar-soaked steel with baking soda to neutralize the acids, even so, as soon as the metal was dry, it began to rust. This is why coating the inside of your barrel with a thin coat of oil is so important. The oil will keep the oxygen away from the metal, which will prevent the oxidation or rust of the barrel. I hope you found this video at least somewhat educational and provided you with some information about this chemical process and its effect on gun steel and lead that you did not already possess. And please share this video, like it, subscribe. Thank you.